In today's video, we are going to talk about a technology which is going to bring a revolution in the field of blockchain. Be it DeFi, NFT, or gaming industry in blockchain, everything gonna be impacted by this technology. And this is not something which I am saying, but this is also something which is also said by Vitalik Buterin. And the name of the technology is zkEVM. Now, the greatest problem in the blockchain world till now we have faced is that blockchain is not that much scalable, right? And zkEVM is the solution to this problem. With the help of zkEVM, we will be able to make our blockchain highly scalable, and not only scalable, but more privacy oriented. So in this video, we are going to focus on what is zkEVM, the types of zkEVM architecture, and so many different things with the help of practical examples. So we are going to deploy a real smart contract on a zkEVM layer 2 solution, and we are going to see each and everything practically, like how zkEVM actually works and how it's going to change the field of the blockchain, how it is going to bring a revolution in the field of the blockchain. So I'm highly excited for this video. If you're also excited for this video, do let me know in the comment section of this video that you are excited. And with this, let's start with our course. Now let us understand what is zkEVM. And before understanding zkEVM, we need to understand how this zkEVM word came into picture. Like if you will see this zkEVM is composed of two words. First one is zk, that is zero knowledge proof, and second one is EVM, that is your Ethereum virtual machine. And when you combine these two different things together, what you get is zkEVM. And we are going to talk about it in much more detail, but for now, let us understand what is this zero knowledge proof and what is this EVM. Because if you want to understand what is this zkEVM is, you need to understand what is EVM and what is zero knowledge proof. Otherwise, it will be very confusing for you. Okay, so let us understand first of all what is EVM. And in order to understand EVM, we will start from scratch. Okay, we will understand how actually a program is executed on our machine, and then we will talk about EVM. I'm going to tell you this because this will actually help you in understanding what is the application of EVM. Okay, so let us understand this, how actually a program is executed on our machine or on our computer. So let's say we have this program, and this program is something which is written in high level programming language, means high level programming language, right? Like for example, if you have coded in C or C++, Python, or whatever programming language you have studied so far, all these programming languages are actually high level programming languages. Now what do I mean by high level programming languages? High level programming languages are those programming languages which are actually human readable. So you can easily read what is written in your programming language, in your program, right? Now this high level program is something which your computer cannot understand. So you need to convert this high level program into low level instruction set so that your computer can understand what is actually written in your program. So what you do is you give this program to your compiler or interpreter depending upon the programming language. Like for example, if you are using C, then you give this C programming language to compiler, and if you are using, let's say, Python, then you are going to give your Python code to the interpreter. Okay, now once you will give this to your compiler / interpreter, this high level program will get converted into low level instruction, or I will say low level code. Now this low level code is something which is actually easily understandable by our computer or by our machine. Now this is a process from which our program, which is created in high level programming language, gets converted to a low level instruction set so that we can execute it on our computer machine. Now let us understand the same scenario in a smart contract, for a smart contract actually. So let's say we have this smart contract that we have created using our Solidity programming language. And smart contract is nothing but this is also a program, right? So just like your C, C++ program, you have this special program that you have written for the blockchain, right? Now, in order to run this smart contract program, again, you need to give this smart contract program to a compiler. And in the case of Solidity, the compiler name is Solc compiler, right? So you give this high level program to this Solc compiler so that you can execute this program on the blockchain, right? So once you give this program to this Solc compiler actually gives you two output. First one is your ABI and second one is your bytecode. But for the purpose of this video, we are going to consider only bytecode so that we can understand the whole process. Now this bytecode, if you will see, is nothing but this bytecode is also a low level instruction set. Just like in our previous slide, we have converted our high level program to a low level instruction set, right? In the same way, this bytecode is nothing but this bytecode is also a low level instruction. Now you give this low level instruction, but where you give this low level instruction to execute? You give this low level instruction to execute on EVM, your Ethereum virtual machine. So you can see that there are a lot of similarities between the previous slide and this slide. The only difference that we are seeing here is that instead of our machine, which actually exists in the real world, right, we have this Ethereum virtual machine. So by the name, it says that it is a virtual machine. And this virtual machine is something which is actually made for Ethereum blockchain. That's why we say it as Ethereum virtual machine, right? And what is a virtual machine? So if you have used, let's say, VirtualBox, for example, let's say if you have this Windows system and you want to run Ubuntu program on it, Ubuntu operating system on it. So what you do is you install this VirtualBox and then you can easily run your Ubuntu operating system on your Windows operating system. So in the same way, we have this Ethereum virtual machine, which actually help us in executing this smart contract code. Okay, and in order to use this EVM, you need to simply install either Get or Parity type of clients, which will actually help you in having this Ethereum virtual machine. So what is Ethereum virtual machine? The Ethereum virtual machine is a decentralized virtual machine that executes your smart contract on the Ethereum blockchain. And the EVM is a software-based emulation of your physical computers. As I said, right, this is a virtual machine. It is not a physical computer. Like we have a physical computer where we are doing all the stuff, but this is not a physical computer, but it is a virtual computer, right? So similar to other virtual machine. And yes, there is one more important point, that it has its own instruction set and operates independently of the hardware, underlying hardware. So it does not matter that which hardware you have, which computer you have. If you can run client software like Get or Parity on your system, you can easily run on Ethereum virtual machine. And not only that, this Ethereum virtual machine has its own instruction set, like your computer has its own instruction set. So this Ethereum virtual machine also has its own instruction set. We have talked about it, right, in the blockchain course in the Ethereum module, that we have this opcode list that is provided by the Ethereum blockchain community, and like these opcode lists are something which actually help us in executing our smart contract on the Ethereum blockchain. So if you haven't watched that video, please do watch that video. It will be very helpful to you. And last but not the least, that smart contracts are written in high-level programming languages such as Solidity, compiled into EVM bytecode that we have seen in the previous slide. This bytecode can then be deployed on the Ethereum network and executed by the EVM, right? And in the same way, you can see that I have covered so many different points. So all the notes related to this particular lecture I have provided you in this slide. I will share the slide in the description of this video so that you can refer this slide later. So all the important things I have mentioned in this slide, so that you can refer it later. Okay. So now we have understood what is this Ethereum virtual machine, right? So this Ethereum virtual machine is simply a machine with the help of which your smart contract can easily run on the Ethereum blockchain, right? Now, what is this zero knowledge proof? Let us understand this. So a zero knowledge protocol is a method by which one party, the prover, can prove to another party, the verifier, that something is true without revealing any information apart from the fact that this specific statement is true. I know this is mind-boggling, right? Like, what is this written here? Like, the prover has to prove something without revealing any information apart from the specific statement is true. Oh, I know. It's confusing, right? But let me give you an example so that you can better understand this. So now, let us say that we have Reena, who is driving this car, okay? And while she is driving this car, she finds a policeman. Now, this policeman, when this policeman sees Reena, he asks for Reena driving license so that he can verify whether Reena is above 18 or not. So Reena, in this case, provides her driving license to this policeman that, okay, my age is above 18. Let's say Reena is 24 years, for example, or any, like you can take any value like 30 years. So now once this policeman verifies that, okay, Reena is above 18, he gives this identity card, this driving license back to Reena, and this is how we usually operate in our life also, right? By providing this driving license to the person who is asking the policeman, and then we can go in our own way. But in this particular scenario, if you will see, we have some issue. And the issue is that Reena needs to reveal those information also to this police officer which are not needed. For example, this driving license will also have details about the house where Reena actually lives. And this is something which is not needed in this particular situation, right? Because this policeman just needs to verify whether she is above 18 or not. But she need to provide all the important, like all those sensitive information, even though it is not required to this policeman. And this policeman now has this sensitive information of her, right? So can we avoid these type of situation where we do not have to reveal those sensitive information which are not required at the time, right? In this case, as I said, the whole house address is not required at this particular time. So what we can do in this case, the alternative can be to use zero knowledge proof. Now Reena will provide her age information not to the police officer but to this black box. Now we will talk about this black box. So as for now, Reena, instead of providing the information directly to the police officer, will provide her age to this black box. And when this policeman needs to verify whether age of Reena is above 18 or not, so this policeman will ask from this black box, okay, whether age of Reena is above 18 or not, and this black box will then tell to the police officer, yes, her age is above 18, or let's say her age is not above 18. And by this particular process, the verification of the information will take place. And in this particular case, if you will see that zero knowledge protocol is a method by which one party, so in this particular case Reena was the prover and this person was the verifier, that something is true. What is true? That she is above 18, right? Without revealing any information. So she does not reveal like any important information, only the age part, that okay, my age is 19, right? Apart from the fact that this specific statement is true. So okay, that Reena in this case provided her age only, nothing else, and by providing this, she was able to convince this policeman that okay, I am above 18. And what is this black box here? This black box is nothing but this is your, I will say, your zero knowledge proof algorithm. You can think like that. So with the help of this zero knowledge algorithm, I was able to generate this proof whether Reena age is greater than 18 or not. Now how this actually works, how this black box actually works, we will talk about this in some other video. But for now, just understand what is the zero knowledge proof. Definitely, if you will comment below in this video that I want a video on zero knowledge proof, I will make a separate video on the zero knowledge proof in much more detail. Okay, but for now, this is what zero knowledge proof is, that you do not need to reveal those information which are not required, and you only provide that particular information and not only directly to that particular person. Like in this case, as you said, you can clearly see that I am not providing any information directly to the verifier, but I am providing this to this particular black box, and this black box is something which is actually being used as a mediator, which is verifying my on the behalf of Reena and providing the same information to this police officer. Okay, so now we have understood what is this EVM, and we have understood what is this zero knowledge proof, and now let us understand this zkEVM. So this zkEVM is nothing but this is a virtual machine. So like Ethereum virtual machine, this is also a virtual machine, and this virtual machine has two capabilities, and these two capabilities are, first one, this virtual machine supports zero knowledge proof protocol, and second thing that this virtual machine supports is this EVM compatibility. Now what do I mean by EVM compatibility? Means like you can run your smart contract on the EVM, right? In the same way you can run your Solidity smart contract on this zkEVM virtual machine as well. So you do not need to make any convergence to your Solidity smart contract in order to run on this zkEVM. So till now you have executed all your smart contract on the EVM. In the same way you can execute all your smart contract on the zkEVM. So it is EVM compatible, and this whole solution is a layer 2 solution. Okay, we will talk about what is this layer 2 solution in detail in some other video, but for now you can think of it as a solution which actually improves the scalability of the blockchain. Okay, now this zkEVM has two major benefits. It can have many benefits, but the two major benefits are that it supports privacy and scalability. And scalability, as I said, is the biggest issue which till now blockchain has faced. Now zkEVM is solving this scalability issue, and not only that, the scalability issue is not coming alone. This scalability issue is also solved along with the privacy one as well. So it is not only providing you scalability but also providing you with the privacy, and which is also great, right? So this is what zkEVM is. Okay, Now let us understand the working of zkEVM so that we can better understand like how it is actually able to improve the scalability of the blockchain and what other features it's going to have, which are going to be very useful to the blockchain community. So let us say that we have this Harry. Okay, now Harry wants to deploy his smart contract on, let's say, Ethereum blockchain. So he thought, okay, why not to deploy my smart contract on the Ethereum blockchain, and then I will be making some money from it. Okay, let's say Harry is deploying some decentralized application. But then Harry realizes that Ethereum blockchain is a very costly kind of blockchain because it consumes a huge amount of gas and it is very costly in nature. Now Harry was sad after knowing this, right? He was very sad that, okay, now I'm going to make some money because I'm losing so much money, right? So someone told Harry, let's say me only, like CodeEater told Harry that, okay, hey Harry, don't worry, we have the solution by the name of zkEVM where you can deploy your smart contract, and by deploying your smart contract, you will be getting the privacy as well as the scalability of the Ethereum blockchain. Now, as soon as Harry find this particular solution, he was excited again. He thought, okay, that's a great solution. Now I'm going to deploy my smart contract on the zkEVM so that I'm saving my money as well as I'm going to enjoy the benefit of the Ethereum blockchain. Now let us understand how this whole process will work. So let's say when Harry will deploy his smart contract on the zkEVM or the layer 2 blockchain, okay, this zkEVM will use these cryptographic techniques and zkProof in order to run this particular smart contract. Okay, so it use all these cryptographic techniques in order to run this smart contract, to check this smart contract, and each and everything will be done, and then this zkProof will be generated. So like we have seen, right, how zk knowledge proof actually works. So by this zk proof will be generated. Okay, when all the computation on this smart contract will be done, and when this smart contract will be on the zkEVM, so zkProof will be generated. Now this zkProof with the transaction will be given to the Ethereum blockchain so that Ethereum blockchain can validate this transaction, whether each and everything is done properly or not, whether this transaction is valid or not. All these important things will be done by the Ethereum blockchain, and once this validation is done, then this transaction will become the part of this Ethereum blockchain as well. And this is how our zkEVM works. And in this case, if you will see how it is actually helping the Ethereum blockchain. Now, instead of running this smart contract directly on the Ethereum blockchain, we are running this smart contract, we are deploying this smart contract on the zkEVM blockchain. So this is actually taking off the burden, right, from the Ethereum blockchain, because if this smart contract, let's say, directly ran on this Ethereum blockchain, in that particular case, this Ethereum blockchain resources will get consumed, right? Because then the Ethereum blockchain need to verify it, need to check it, and all those different things has to be done by the Ethereum blockchain, which will consume all the resources of the Ethereum blockchain. Now, instead of running this smart contract directly on the Ethereum blockchain, what I did is I run this smart contract on the layer 2 solution of the zkEVM blockchain, and by this I was able to free of the resources of the Ethereum blockchain so that Ethereum blockchain can be utilized for other important purposes. And not only that, it also saved me a lot of money, and I was enjoying all the cryptographic techniques, benefits me, the privacy and everything of the zkEVM blockchain. Now this is the beauty of zkEVM. Okay, and now let us understand this by deploying a real smart contract on the zkEVM layer 2 blockchain so that we can see how actually all this process work that we have seen theoretically in real life. So now let us understand this zkEVM with the help of Polygon zkEVM example. So Polygon recently has launched its zkEVM mainnet beta, but we are not going to go for that for now. What we are going to see is what is this Polygon zkEVM and how it actually works. Okay, so if you will see Ethereum scalability with zkEVM performance and security. So it is of low cost, high performance, EVM equivalence and security. So you can clearly see that deployment into EVM without changes in code means whatever you are doing on the EVM blockchain, you can do the same thing on the zkEVM blockchain. Means not the blockchain, actually a layer 2 solution of the Ethereum blockchain. Okay, and if you will go below, you will see that we have this user transactions. Okay, so they have given this example, beautiful example. So we have these user transaction. We are providing these user transaction to these zkEVM RPC nodes, these layer 2 solution blockchain, as you can see. And now we are actually providing all the transactions once they are executed on this particular blockchain for the validation purpose to the layer 1 Ethereum blockchain. Okay, so this is how actually this is done. Okay, first of all, you give your transaction to this blockchain. Then actually when I'm saying blockchain, and again do not think that this is any separate kind of a blockchain. It is a layer 2 solution of the Ethereum blockchain. Okay, that's what I'm trying to say. Then it is going to the layer 1 Ethereum blockchain. Okay, now let us see how it actually works. So in order to do that, we need to go to the okay, so now we are on this page, wiki.polygon technology docs zkEVM/develop. I will share the link in the description of this video, so don't worry about it. But for now, in order to use zkEVM, what we need to do is we need to make some changes in our MetaMask wallet so that we can connect to the zkEVM layer 2 solution. And how we can do that? So first of all, we need to go to our MetaMask wallet. Okay, so once we are inside our MetaMask wallet, you need to go to you need to click this button, then you need to click on this settings option, then you need to go to this networks tab. Now in my case, I am going to zkEVM, but in your case you might not be have this zkEVM, so you need to click on this add network tab. Okay, but I am clicking on this, you need to click on this. So once you will click on add network, you will see an empty layout, right? All these things will be empty in your case because you have clicked on add a network. And then what you have to do is you have to simply copy paste these things, okay, that I have copied in my MetaMask dashboard, okay, in the settings dashboard. So you can copy all these things from this zkEVM testnet. This is the RPC URL, this is the chain ID, and this is the blockchain explorer where you can see your transaction. So the same things I have copied down in my MetaMask wallet. Okay, so once you will do that, your MetaMask wallet will be ready, okay, with zkEVM testnet, because we are using a testnet. Okay, and we are not going to use the real zkEVM because it will be costly to us. We need to pay some amount of money, which we do not want to do. So we are going to use the zkEVM testnet. So you can see that now I have this zkEVM ready. Okay, and now if you will see in my account currently there are some amount of ether, but in your case your account will be empty if you are first time using zkEVM. So now you need to transfer some amount of fake ethers in your zkEVM account so that you can deploy your smart contract, right? So how you can do that? So instead of you do not have any zkEVM faucet, okay, you need to do you need to use the concept of bridging here. Okay, so you need to scroll down and you need to go to this Polygon wallet suite. Now once you will go to this Polygon wallet suite, okay, so now we have this dashboard. And in your case, if you are seeing for example Ethereum here, so switch to the test network part. Like currently I am on my testnet part, okay, so that's why it is showing Gorilla. But in your case it might be showing, let me show you, this Ethereum. So if it is showing Ethereum in your case, do not worry, just click on this try testnet, which is given bottom bottom left. Okay, just click on this try testnet. Now once you will click on try testnet, you will see Gorilla option. Okay, now once you will have this Gorilla option, what you need to do is you need to connect your MetaMask wallet to Gorilla test network. Okay, so once you will connect to your Gorilla test network, now what you need to do is you need to simply transfer some amount of actually you need to swap some amount of ether from your Gorilla account to your zkEVM account. So currently if you will see, the account number are the same, so it is 0465, and if I will switch to zkEVM, it is 0465. The amount ethers are changed. So what we need to do is we need to simply do some amount of transaction so that we can transfer some amount of ether, right? We can swap some amount of ether from Gorilla test network to our zkEVM accounts. So for that you need to simply type, now in my case it is pretty low, so I will simply use 0. Let's say 01. Okay, in your case if you have some more Gorilla, you can definitely transfer it, and then you have to simply click on this bridge ETH to zkEVM testnet. Okay, and just click on it. Now once you will click on it, it is asked for your signing process. So just sign this by entering your password. Just click on confirm. Now once you will do that, you will see that ether will be detected from your Gorilla testnet account and it will be transferred to your zkEVM account. Now this will be a time taking process. It might take 10 to 15 minutes also. Okay, so you need to have some amount of patience here. So if you will go to Etherscan, you will see your transaction. It will take some time. Okay, so if it is taking some time, just don't worry, just wait for some time. It will go from this pending state to the success state. So if you see some amount of you can clearly see, right, that some amount of ether are in pending state, so I need to wait for some time. But in my case, I already have some amount of ether in my zkEVM account. So what I'm going to do is I'm going to show you how it is done. So you need to wait for some time. Once you have some amount of ether, you can again you can do the same thing with me. Okay, otherwise what you can do is you can simply see what I'm trying to do here. So I'm going to my Redmx ID. And now what I will do is I will simply deploy this smart contract. Okay, a simple smart contract. You can choose any smart contract of your choice. Just select your MetaMask from here so that you can connect to your MetaMask wallet. So currently you can see that I have connected with my zkEVM, okay, testnet. So custom 1442, and this is the account address. Now I'm going to deploy this, okay, and we are going to confirm this. So now we need to wait for some time for the transaction to get confirmed, and it is confirmed for now. Let me go to the block explorer. So this is your transaction, and your transaction is successful, but you need to wait for some time. Like currently you are seeing that you do not have any option of L1 sequence hash. Like after some time, I think around 5 to 6 minutes or 10 minutes, you will start seeing this L1 sequence hash, which will be the hash that is generated on the Gorelli Ethereum blockchain. Let's wait for some time and I will show you that. So let's wait for 10 to 15 minutes and then I will show you that. So now you can see that we have this L1 sequence hash, and it took around, I think, 15 to 20 minutes to get generated. In your case, it might take 15 to 20 minutes or even more. So just don't worry. Once your transaction is done, just wait for some time so that you can see this L1 sequence hash. Now, what is this? I'm going to tell you. Just don't worry. For now, let me tell you what actually happened during this while. So once we deployed this smart contract, okay, on the zkEVM layer 2 solution, so we have this contract address, and you can see that we have this contract address here also, right? So we have this contract address, and this is the account from which this transaction is done, right? So this account. Now if you will click on this L1 sequence hash, okay, if you will visit this, you can clearly see that you have this transaction done on the Gorelli test network as well. So as I told you in the PPT as well, once you do your transaction on the zkEVM, your smart contract and everything, get computed and deployed here. But one transaction is also generated which validate your transaction, means which validate whether everything is done in a proper way or not, and a zkProof is generated so that this Ethereum blockchain can verify it. So if you will see, now we have this on the Ethereum blockchain as well. So we have this contract and everything on the zkEVM, and then we have this Gorelli test network where we have the we have this transaction stating that, okay, one transaction is done on the zkEVM, right? And one more important thing that you will notice here is that we have this contract address. As you can see that we have this contract address. Now what is this contract address, right? Because this contract address, as you can see, this is the contract address of our smart contract. But what is this particular smart contract address that you are seeing on the Gorelli blockchain? Let us understand this. And to understand this, we need to understand the zkEVM architecture. Okay, so let us understand the zkEVM architecture so that we can understand the meaning of this contract address. And yes, before moving further, let me clarify one important thing: whether zkEVM has a layer 2 blockchain or whether zkEVM is a blockchain or what. No, zkEVM is not a blockchain. So let me clarify this confusion if you have this. So zkEVM is a layer 2 scaling solution for Ethereum that uses zero knowledge proof to enable trustless and secure off-chain computation. Okay, so the computation that is done off-chain. And if you will go to the second point, so to answer your question directly, that zkEVM does not have its own layer 2 blockchain. So zkEVM does not have its own layer 2 blockchain. Okay, so this is the layer 2 blockchain, layer 2 solution which is built on the Ethereum blockchain. So but rather it operates as a layer 2 solution on the top of the Ethereum blockchain. So zkEVM is not a blockchain itself. So zkEVM is not a blockchain. It has a layer 2 solution that is built on the top of the Ethereum blockchain and operates off-chain using zero knowledge proof to enable secure and trustless computation. This means that all transaction and smart contract execution are ultimately settled on the Ethereum blockchain. So each and everything is settled on the Ethereum blockchain, but they can be processed off-chain using zkEVM to reduce the load on the main network and increase the transaction throughput. So if we talk about zkEVM architecture, it has three components. First one is the execution environment, where we actually execute our smart contract when we let's say deploy it on the zkEVM layer 2 solution. Then we have the proving circuit, which actually generates the zero knowledge proof, okay, which can be verified by the Ethereum blockchain. And then we have the verifier contract. So this verifier contract is nothing but this is a contract that is deployed on the Ethereum blockchain, okay, which verifies the proof generated by the proving circuit. So if you will see this verifier contract, ZK rollups submit validity proofs to a smart contract deployed on the L1 chain, means on the Ethereum blockchain for verification. the input and output are also submitted to the verifier contract. Means each and everything is submitted to this verifier contract for the verification purpose. Then the verifier runs computation on the provided proof and confirms that submitted outputs were correctly computed from the inputs. So this is done like this is like a verification being done once we have this proving circuit generate this zero knowledge proof. So the proving circuit produces a zero knowledge proof verifying the validity of the transaction computed in the execution environment. Then zk rollup submits this validity proof to the smart contract, and with the help of these three components we create this zkEVM architecture. So now if you will see this contract address, right, this contract address that you're seeing here is nothing but this is a verifier contract. Okay, so this is your verifier contract with the with this with which our zk rollup is doing this submitting our zk rollup is submitting the proof to this smart contract, to this verifier contract that you are seeing on your screen. Okay, and this is some unknown address. I think this is something done by from the polygon side. I do not know about it. I am honest, I will be honest with you, I'm not sure like how this is done, like who is doing this, but most probably this is done by polygon. And if you will see that from polygon side to this verifier contract, we are actually transferring some amount of tokens, so that because they are doing some amount of work, right, for the verification and everything on the Gorilla. So I think this is done in this way. Now let me do one transaction here. Okay, let me do one transaction here at this contract address. So for now, if you will retrieve the value, it is 0, but now let me make it 10. Let me call this. So let me confirm this. So now the transaction is confirmed. So if we will go to the blockchain explorer, we can see that we have this transaction done on the zkEVM layer 2 solution. Okay, and if you wait for some time, again you will see that an L1 sequence hash is generated, which you can verify on the Gorilla test network. So we need to wait for some time so that we can see that as well. So now after some time, after 4 hours, I will say, you can see that we have this L1 sequence hash. Okay, and when I will click on this, it will take us to the Gorilla test network, where we can see again from address and the verifier contract address, right? And from this address to this address, again, the same scenario is there. And you can see that how it actually happened on the Gorilla test network and now actually happened on the zkEVM layer 2 solution. Now let's talk about the types of zkEVM. So this list is actually given by Vitalik Buterin. You can see the source here by clicking on the source link, and I will provide you the slide so that you can refer it later also. Okay, now so you can see that Vitalik Buterin has actually categorized these zkEVM on the basis of two things. First one is the compatibility, means whether the zkEVM are EVM compatible or not. If they are not EVM compatible, means they like when we deploy our smart contract, for example, if the zkEVM is EVM compatible, highly EVM compatible, in that case we can directly deploy our smart contract on the given EVM, okay, zkEVM. But if it is not highly EVM compatible, in that case we need to make some changes to our Solidity code, and then we can deploy it on the zkEVM layer 2 solution. So you can see that highly compatible means they are compatible to the EVM, so that we do not need to make much changes to our Solidity code when we want to use the zkEVM. So if you will see that this we have this 1, 2, 2.5, 3 and 4, and if you will see this first one, that is the zkEVM community edition, it is highly compatible, right? It is highly EVM compatible, but the performance is pretty low. Performance is pretty low means it is very slow, so it will take a long time to generate proof. As you can see, which proof? The zkProof. And if you will go to 2, it is less compatible, and I will say it is in a middle ground, like 2.5 also, which is also in a middle ground. But if you will come to 3, this 3, that is scroll and polygon herms, in this case you can see that they are faster in generating the proof, but they are less EVM compatible, means their compatibility as compared to the first one is pretty low, right? This is pretty low. So you need to make certain changes to your Solidity code or some minor changes so that you can deploy it on the polygon herms or scroll. So can verify an environment that is similar to Ethereum, but with minor changes. As I said, right, you need to make some changes to your contract or to the application layer, or some touches are needed in order to deploy it directly on the zkEVM of scroll or polygon herms. So fully compatible with most Ethereum apps, can share a lot of infrastructure, faster to generate proof. And if you will see the fourth one, that is zk Sync 2.0, neither minds wrap. So in this case, you can clearly see that they are fastest in proof generation, but they are very less compatible. So compile codes written in Solidity, Viper or other high level language to a specialized VM and proves that. So not compatible with the Ethereum apps, even though they are highly, performance is pretty high, but they are not much compatible with the EVM part. So if they are not much compatible, so you need to make a lot of modification in your Solidity code or other things as well. Let's say, in order to directly deploy it on the ZK Sync or Nethermind's zkEVM. So I've also provided you these types of zkEVM. Let's say if you want to learn about polygon zkEVM in much more detail, so you can learn from there, okay, from this particular slide. In the same way, I have provided about zk sync as well. So if you want to explore like how they actually work, right? I have told you the generalized way, but if you want to learn about how polygon zkEVM works, you can definitely refer this slide. So if you will see how polygon zkEVM actually works is the EVM bytecode that we generate is compiled into micro opcodes, means the compiled bytecode is generated into a micro opcode, and this micro opcode is executed on a UVM, okay, so another type of virtual machine, which actually uses your snark and stark proofs. Means what are these snark and stark proofs? These are actually types of your zkProof. We will talk about this in some other video. If you want a video on this, do let me know in the comment section, okay? And if you will see in the same way about zk sync, so it uses your compiled code, and contract code is written in Solidity to Yule. Means whatever code you have written in Solidity, you convert it into a Yule programming language, which is much more closer to your assembly programming language, and then you use this Yule programming language in order to deploy it on the different virtual machine. So this is a different way of working with the zk sync zkEVM, which is very much different from this polygon zkEVM, where the bytecode is generated into micro opcodes and executed on the UVM. But in this case, we are converting our Solidity to Yule, and then we are actually deploying on the virtual machines, right? So I hope you enjoyed this particular video, and if you have enjoyed this video, do let me know in the comment section below. Okay, in this video we have talked about so many different things. We talked about what is zkEVM, the different types of zkEVM architecture and its working, and each and everything with the help of a practical example, right? We actually deployed a smart contract on a zkEVM layer 2 solution. So if you have enjoyed this course, do let me know. Do let me know in the comment section, and do subscribe this channel if you want regular blockchain courses, and the notes and everything is attached in the description of this video so that you can directly download from there. And if you have liked this course, you will also like my this course where I've talked about Oracle, and this course where I've talked about Solidity in depth. So watch these courses and meet you soon in the next video. Take care. Bye bye.